Advanced Data Manipulation Language, or DML, Part 3 of 3. This nugget is particularly important, and I know you've heard me say that before in this nugget series. However, understanding joins is truly crucial to your success as a database administrator, not only with MySQL, but with any RDBMS. You also need to know joins fully and completely for your certification exams as well. We can't neglect that point. At any rate, our agenda for this nugget is as follows. First, what are table joins and why do you use them? How do they improve your lives and the lives of your users in your MySQL database? We'll then get to where the rubber meets the road, and I'll show you the syntax for defining joins. The two types of joins that we'll look at in this nugget are really the two major ones. Inner joins, formerly called cross joins back in the day, so to speak, and we'll also look at a less frequently used but still helpful type of join called the outer join. So join me, so to speak, and let's get to work. What is a join, and why would you as a MySQL DBA think to use them? First, let me give you the purpose, then I'll define specifically what a join is. A join is crucial for performing two types of operations in any RDBMS, but specifically in MySQL. First, we use joins to extend select queries across tables. You can actually create joins that include up to 61 tables in MySQL 5.1. Why is that important? Well, we'll recall that in a fully normalized database, we're separating out our data as granularly as possible into separate tables. And the purpose of this is, the purpose of normalization, I should say, is to reduce or eliminate data redundancy. Now, in doing so, you may want to reference another table in one table for, again, the purpose of joining them together. I'll give you an example down here in just a second. The other chief benefit of using table joins is something we've already seen in previous nuggets. In MySQL, we can do updates and deletes that affect more than one table. Well, unless you have the basis of a table join defined in those tables, you're not going to be able to do this. It's as simple as that. We'll also recall as a point of review that the basis for joining tables together is to create a matching key field. Now, I'm not specifically talking about the foreign key constraint yet. We've already talked about that earlier. And also, only some MySQL storage engines support foreign key constraints. You remember which one, right? Yes, it's the InnoDB, which is not the default storage engine in MySQL 5. You need to keep that in mind as well. But at any rate, to do table joins, regardless of the storage engine being used, we need to make sure that we have a matching column. Now, in this example down at the bottom, which I borrowed from a really great website called sqlzoo.net, definitely check it out. There's some interactive stuff on table joins where you can actually interact with sample data using MySQL syntax. Definitely check it out. It's a great instructional site. In this sample database, we have two tables, one called country that obviously tracks countries by a key field called ID. Now there's another table that deals with games, evidently, that tracks game information, and I'm sure it has its own key field that's not shown in this output. But we have a games column, a color column, a who column, and then because it's, in this particular example, a case of more than one country showing up in more than one game, instead of doing data redundancy and actually creating a country field or set of country fields in TTMS, we're defining a matched column, in this case called country. You know by now that we have to use the same data type, although these matching columns do not have to have the same name. As a matter of fact, you see here they do not. In the country table, the key field is ID. In the TTMS table, the column is called country. But you notice that the actual data in each rows is referencing country codes that exist over here in the country table. This is crucial, this matching column business, because these are the columns that will tie the tables together in your join statement. Again, what are the take-home reasons for doing this? One, as I said, to extend your select queries. Now, what does that mean? Well, let's say you wanted to get a list of all the games that took place in a particular year that involved, let's say, two different countries. Well, if we were constrained to querying only the TTMS table, you see that the country feedback we're going to get is not very useful to most end users. After all you'd be retrieving are these country codes. Most people, myself certainly included, would prefer to see the actual name of the country or perhaps some other data that's being tracked separately for that country in another table. Because of this join capability, we can write a query that transparently pulls columns from both tables, such that we could show game, color, who, and the name column from the other country table. You see? That's how we extend select queries in a join environment. And of course, as we've already talked about, we can do multiple table updates and deletes as well. Inner join syntax, part 1 of 2. MySQL gives us two different syntaxes for defining joins. The first one I'm showing you is the more orthodox syntax. And if you have any plans of sharing any of this data between MySQL and a different RDBMS, then I would suggest you use this syntax, as I said, because it's more portable and used by other systems. For instance, Microsoft SQL Server uses a join syntax exactly like this. Now, how does it work? Let's look right at the code first. To run a select statement that pulls columns from more than one table, you first, in your column declarations, specify those columns transparently. In other words, in this sample, we're saying select who, comma, name. Now we know that the order of these is important because, well, it's important in as much as if you want the who column to appear first and the name column to appear second, we have to list them that way after the select statement. But also I want you to see what's going on here. We're taking who, but we know as we're designing the query that who is going to come from the TTMS table and name is going to come from country. Now, of course, the question comes up, do we have to qualify these column names? In other words, should we say select ttms.who, country.name? The only time you have to do that is if MySQL will get confused as to the column names. For instance, if we were going to pull, if there was a column called name in TTMS, in that case we might run into some problems in terms of ambiguity. So you'd want to say select ttms.name, country.name. But in this case, these are distinct columns, and because MySQL is about to be notified where those columns live, we don't have to worry about qualifying them. Now, the from statement in this syntax is key to defining the join. Now, you notice that it says from TTMS inner join country. I guess I should define an inner join before going any further, right? An inner join I like to define, graphically at least, by using this syntax, two interconnected rings, where we could imagine those rings representing tables. So we have the TTMS table and the country table. And each one has its own respective row set. And when we define an inner join, we're gathering the records or the rows that are matched on a particular column between the two tables. Now, when we talk about outer joins, there you get into what's called the left join and the right join. The order that you declare your tables in your from statement is important, obviously. But for an inner join, it actually doesn't matter, as I say down at the bottom, whether we said from TTMS inner join country or if we said from country inner join TTMS. They're both equivalent statements because, again, to say it one more time, we're pulling records based on matching values on a particular column. And that actually is the third clause here in our select statement. So we have the inner join declaration, and then immediately we say on, and then we have to qualify using table.column syntax exactly what those columns are that tie the two tables together. So in this case, we're taking ttms.country on one side, and we're setting those records equivalent to matching values in the country.id table. You see how that works? And then we see over on the right a sample run of those results. We get the two columns, and then we get any rows that match on those two tables. So it looks like in this case there are 3 records. Inner join syntax 2 of 2. Now let me show you the alternate way to write an inner join in MySQL. Now this is what I call the non-orthodox way, and it's kind of a shorthand quick and dirty way to write the join syntax, this syntax is definitely nowhere near as portable as the first one I showed you. Another difference you'll see is that in this case the join declaration is not given in the from clause, but it's put down in the where clause, which on first blush might sound a little bit confusing to you. After all, what if you wanted to actually include an honest-to-goodness where declaration? Well, I'll cover that in just a second. First, let's look at what we've got going on with the sample code. Here we're saying select who and color, which we presume are columns in two separate tables. In the from statement, we give those tables in a comma-separated list. Again, the order here is irrelevant because we're dealing with an inner join. If we were dealing with a left join or a right join, then certainly the order of the tables is important. Notice that, as I said, the join criterion is put in the where clause. Now, in one sense, this is a more compact syntax for sure. This is the syntax that we used, for instance, earlier in this course when I showed you how to do multi-table updates and multi-table deletes. And we're simply saying here where ttms.country equals country.id. In other words, we're linking up the two matching columns on either side of the join. And then the sample result here, we get 2 rows back. Now, if we needed to do further filtering on this data, all we would do if we wanted to add the filter to the where clause is specify and. We're already familiar with the and logical operator, aren't we, from our earlier nugget on using the select statement. For instance, we could say where ttms.country equals country ID and color equals bronze. You see what I mean? You could simply use the and to connect your join declaration with any other further row-level filtering that you desire. Also, we have the ability to use group and having with either of these syntaxes. Review the previous nugget we did on aggregating data from the select statement for more information on this. But you notice in the sample code below, we're selecting the row count and name from 2 different tables on a criteria, and here we're grouping by name, which is a nice thing to do, grouping is, when we're using aggregate functions like count, and we're even specifying filtering on that resultant data. Remember that having is distinct from where in terms of when the actual filter's applied. Having is going to apply to the already filtered results, okay? The perhaps lesser known, lesser understood, lesser used join type in MySQL is called the outer join. And outer joins are a special type of join that are used to retrieve non-matches in table sets. So as opposed to the inner join, which links tables based on matching values in a certain key column, outer joins also use a key column, but we're gathering matches and non-matches on one of those 2 tables. That's where we get the idea of left join and right join. So we would simply write our syntax for the outer join, specifying left if we wanted non-matching records coming in from the left table, and we would use right join if we wanted to get matches and non-matches that originate from the right table. Because we have recto verso left right, table order is crucial when you're writing your outer join statement, for sure, because the first table you specify in your from statement is going to be de facto considered the left side of the join, and the second table you reference in your join statement, de facto, will be considered the right table in that join. If you want to do kind of the opposite, by opposite I mean instead of grabbing matching and selective non-matching records, you could grab only the non-matching records from the left or right side by simply inserting a where clause that specifies null for a particular value. Before we dive into the demo, let's look at some examples of using outer joins. Example 1 reads, select name and language, which we presume are columns from 2 separate tables, one country, the other country language. And in this case, we're using from table 1, that's going to be, we know, the left table, country, left join country language, which we know from the table designation order is going to be our right table, on the particular key field. Now, in order to be orthodox, I really should have qualified these with the name of the table. Country.code equals countrylanguage.countrycode, just to be strict. But what this is going to do, of course, is going to grab those two columns that share the same ID value, the code value. And because this is a left join, all of the other records that don't have a matching code in the right table will be included in that query. When would you want to do that? Well, there's plenty of reasons why you want matching or non-matching records. In my experience, I'm looking for the non-matching records specifically, in most cases anyway, and that situation is addressed in code sample 2. Here we're selecting just name from, here we have our two tables, country language, right join country. So here we're swapping the two tables. Country language is our left table, country is right. We're matching them up on their matching column, but check this out, where country code is null. So this is, to draw my little Venn diagram again, is going to, at least initially, look at both matches and non-matches on the right side. But this where statement effectively takes the joined records, throws those out, because remember, by definition, this inner join is defined on matching code values. So if we're throwing in a where, that ID column is null, and we're doing a right join, we're going to grab just the non-matching records on the right table. Similarly, we could do the same thing with left join to pull just the non-matching records from the left table. Boy, I've made a mess of this Venn diagram, but if you've been following me, congratulations, because you've come a long way in understanding how relational databases work. In this demo, we're going to fire up Ubuntu Nugget, log into MySQL Server, and I'm going to show you how joins work from the ground up. We'll look at both inner and outer joins in this demonstration. In this demonstration, we're going to work with joins in MySQL. We happen to be on Ubuntu Nugget here, so let me bring up a terminal window, and you can see I've logged into MySQL Server, and I'm using the world sample database. Let's do a show tables and show that we have city, country, and country language. First query I'd like to run, I want to show you, we'll say select country code and language from the country language table. This gives us a lot of rows. Actually, why don't we limit this to 10? And you can see that in country language we have a country code column and a language. And you see there's a one-to-many relationship in terms of a particular language, or should I say a particular country code, like ABW, whatever that is, right, has more than one language. Dutch, English, Papiamento, that's a new one to me, and then Spanish. Now, let's run another query, select code and name from the country table. We'll also limit this at 10. And the country table, you see, has the actual country code. So it looks like in the world database, the country table has columns for the code, of course, that uniquely identifies each country, and then the name. All right, so far so good. We can see AFG means Afghanistan, but you notice that I'm resolving the codes to a name by using a lookup table. In other words, if we look at just the columns in country language, we have to actually refer to the country table to get the names. Well, you see where I'm going here. The code column in the country table uses the same data type and is therefore our matching column to the country code column in the country language table. If we actually want to see countries by name and their language, we're going to need to write a join expression. The first syntax we'll use is the non-standard one. We'll get that out of the way, what I call the compressed join syntax. And we're going to start with the most common type of join, the inner join. So let's run the first select statement again, in which we grabbed name and language. Actually, this is a modification of the first one, because what we're going to do is take the name column from country and the language column, let's come up again, from country language. So we're taking two different columns from two different tables. And that'd be a really nice setup, because instead of just codes, we should get the countries by name and the languages by name. All right, so select name and language from, and then since this is an inner join, we can list either table first. We could say country language, comma country, or we could do it just the other way around. The third necessary statement when we're doing the non-traditional inner join syntax is to put our on condition, but here we put it in the where clause, don't we? We need to match up our columns from the respective tables. So in our where statement, we're going to qualify the tables with those matching columns. So country language dot country code, and we're going to assign that to country dot code. So those are our matching columns. There we go. Let's bring back that query again. Again, 984 rows is an awful lot. All right, and this time we're going to throw in limit 10. And so there we get our desired result. We get the name of each country as well as their language. Let's take a look at this sample query I just wrote. Select name and language from, this time I'm inverting country and country language just to demonstrate that it doesn't matter in this case, where the country code equals cold. Here I'm not qualifying, I'm living dangerously. But notice that I'm putting in an additional parameter just to show you if you want to use this compressed inner join syntax, that's fine. You can add additional where clauses besides the join one just by specifying and. So here we want to see name and language from country, country language, where the language is English. And there we go, we get 60 rows back. What if we wanted to determine the number of languages spoken per country? Well, this gives us a good example to write a query that invokes aggregate functions as well as the group by and possibly even the having clauses. This is a nice review of what we did in a previous nugget. So look at this query. I'm writing select name and count, and I'm aliasing the count all rows function with the title number of languages. So we'll see the country name and then the number of languages per from the two tables, country, country language, where there's our join declaration. But look what we're doing here. Remember, with aggregate functions, it's almost a given that you're going to be grouping on one of those columns in order to make the aggregation happen. In this case, we'll group by the name of the country. After all, that's how we're going to figure out, for instance, that United States supports, say, 12 different languages by grouping and aggregating all of the language entries for each country. And then if we even want to get more specific, we can throw in a having clause after we've done our grouping, such that the count value we're going to return are only those countries with more than 10 spoken languages per. In this case, we get the following result set back. For completeness, I think it's only fair that we transition from the so-called compressed join syntax to the more orthodox portable syntax that actually uses the inner join, and then we'll move on to left join and right join keywords. So in this query, we'll select name and language, and then in our from clause, we'll specify the tables, country language, inner join with country. And as a point of review, you remember that doesn't matter the order of the tables for an inner join, but it certainly does with outer joins. Third important statement, we use the on keyword to define our matching fields here. This is country, I'm going to qualify here, country language dot country code equals country dot code. So there's our completed syntax. We're going to limit this to 10, and then we get our result back. Fine. So this is an equivalent query to the same query we did at the start of this demo. It's just we're using a different syntax. Alrighty then, let's clear our screen using a really nifty escape character that we have in Linux but not in Windows versions of MySQL, the \! And we'll submit the shell command clear to keep us in MySQL but clear our screen. Let's take a look at the query we just did before, where we're taking name and language from country language and country. We're matching on the field, and let's just submit that batch. We get 984 rows back, and the inner join, you'll remember, takes the two columns that are matched on that key field. So keep a note of that. And also, for every country, we have a language listed. Again, that's by definition by virtue of those code columns. Now, with a left join or a right join, remember, let's start with left join. We're going to take not only the matched fields, but also matched records on the left table, or the first one that we specify. Therefore, if we do again, select name and language, and then in our from statement we say country, left join country language, and then on the two matching values. What's this going to do? How many rows is this going to bring back? You think it'll be 984 less than or greater than 984? Well, let's see. A few more, right? 990, not too many more. Because remember, in a left join, we're bringing not just those columns that are matched on that key field, but as you'll see specifically, these guys right here, we have some countries that do not have a language stored for them, such as the principle of the left join. And we're showing those values. We're grabbing those non-matching records from the first table we specified, you see? So if we bring back this command by using the up arrow to invoke our command history, we'll see that the non-matching records here are coming from the country table, not country language. Now, if we just wanted to see these nulls, or the non-matching rows, you'll remember from the whiteboard portion of this nugget, all we'd have to do is edit this query to throw in a where clause. We'll simply say where, in this case, country code is null. Simple as that, a simple where condition. This will bring back just the non-matching rows from the first or left table indicated in the join statement. And of course, these are countries. We would do just the opposite if we wanted to see the languages and we wanted to see nulls on the other side. Now, we're kind of playing a semantics game when we're dealing with left joins or right joins because there's a couple different ways we could do this. One way to get a right join in this example is, let me get rid of this is null, is to reverse the order of our columns. In other words, we can keep this a left join, but simply swap country language and country. This, in effect, is the same thing as doing a right join. We've just swapped the order of the columns, right? There. Alternatively, we could use the right join statement with the original syntax to gather matching rows between the two tables and non-matching rows from country language. Advanced DML Part 3 of 3 Review. I hope you feel much better about what joins are and how they work than before you started watching this nugget. We looked at initially what joins are, why they're useful. I hope you're very convinced on their utility at this point. Joins tend to scare a lot of newcomer DBAs. Again, it's my sincere hope now that you know what joins are and why to use them, as well as actually how to define them in SQL, that you have much more confidence in the subject. If you understand everything we've done in this nugget, you have no fear for any join-related questions you see, not just on your Certified MySQL Associate exam, but for any of the other exams. I hope that this has been informative for you, and I'd like to thank you for viewing.